This is the Certified Construction Stormwater Operator and Soil Erosion and Sedimentation Control Inspector Training Program administered by the Michigan Department of Environmental Quality Water Bureau. This training will provide the information necessary to become a Certified Construction Stormwater Operator and Soil Erosion and Sedimentation Control Field Inspector. A comprehensive soil erosion and sedimentation control training program is offered separately for individuals that are responsible for the design or review of soil erosion and sedimentation control plans. This training is designed to enhance your understanding of the requirements of the soil erosion and sedimentation control and construction stormwater programs. It will provide you with guidance that will assist you in your duties as a soil erosion and sedimentation control inspector or certified construction stormwater operator, hereafter referred to as stormwater operator. Let's begin with a brief overview of water quality issues, especially where they relate to precipitation, runoff, and the resulting soil erosion and sedimentation from construction activities.
From a raging stream during spring snowmelt to a gentle summer rain, to the slow movement of water through the ground, water is in constant motion. The movement and endless recycling of water between the atmosphere, the Earth's surface, and underground aquifers is called the hydrologic cycle. This movement of water, driven by the energy of the sun and the force of gravity, supplies the water needed to support life. Understanding the hydrologic cycle is an important key to understanding the proper management of our water resources. Many processes work together to keep the Earth's water moving in a cycle. In fact, there are 5 processes at work in the hydrologic cycle: precipitation, infiltration, runoff, evaporation, and transpiration. These occur simultaneously and, except for precipitation, continuously. Stormwater runoff is a part of this natural hydrologic process. Under natural conditions, the majority of rainwater that falls to the ground either infiltrates into the ground or evaporates. However, construction activities can disrupt this natural process by removing the protective cover of vegetation, decreasing the infiltration capacity of the site, and increasing the runoff. Unless properly planned for, the increased runoff may flow onto adjacent properties or into our lakes, rivers, streams, and wetlands. Sediments or other pollutants are also carried along with the runoff to the adjacent properties or surface waters. The volume and rate at which stormwater is discharged from the site must be considered prior to undertaking any earth change activity. There are many water quality concerns associated with stormwater. Sediments, oils and greases, and fertilizers are a few of the more common pollutants associated with construction activities. By far, the most prominent of these pollutants is sediment resulting from unchecked soil erosion. Stormwater management, soil erosion prevention, and sedimentation control techniques are the focus of today's training.
Soil erosion is the movement of soil particles put in motion by wind, water, ice, or gravity. This is a video sequence of rain splash. It depicts the impact that a single raindrop has on dry sand. Moving water may cause shoreline, stream channel, or overland erosion. Overland erosion can be further subdivided into 3 categories. The first is sheet erosion, which is the removal of a broad, thin layer of soil from the land surface. It usually results in the removal of topsoil and can scour the roots of young plants. The second is rill erosion, which occurs when runoff concentrates in a given area. This larger volume of water will scour a path through the soil. The third is gully erosion, which is the result of uncorrected rill erosion. The difference between rill erosion and gully erosion is depth, with gullies being in excess of 12 inches deep. Gully erosion results in substantial soil loss in a concentrated area, but sheet erosion results in the greatest overall soil loss. Although these are natural processes, they are often accelerated by human activities, especially during construction. Sedimentation is the process by which dislodged particles caused by erosion are deposited in another location, either on the land or surface waters, such as our lakes, rivers, streams, or wetlands. When sediment enters surface waters, various negative impacts can occur. Among these are habitat degradation by deposition, increased turbidity, and transport of other pollutants into the system. Sediment deposition can cover the spawning areas of fish and other aquatic organisms. This may discourage the fish from spawning or prevent their eggs from hatching. Voids created by rocks, gravel, and woody debris provide cover for the young fish as well as for the aquatic insects many fish feed on. Filling in these areas with sediment will leave the young fish vulnerable to predators as well as destroy a valuable food source for fish. Suspended particles may adhere to gill structures of fish and aquatic insects, inhibiting the transfer of oxygen. The suspended sediment can lodge in feeding and other breathing structures of aquatic plants and animals, causing starvation or suffocation. The deposition of sediment also affects stream shape, causing the stream to become wider and shallower. A wider, shallower stream is more prone to temperature extremes, which can force cold or cool water fish species to relocate in order to survive. Sediment deposition can decrease waterway depth, making navigation difficult and increasing the need for dredging. Sediment in water will also increase turbidity, which is the cloudiness caused by having soil particles suspended in the water column. Turbid water can inhibit the ability of some animals to hunt by sight, disrupting the natural predator-prey relationship. Such a disruption in the structure of the community can be detrimental to both species. In addition to affecting wildlife habitats, sedimentation can also damage water supplies and degrade recreational uses such as boating, swimming, and fishing. Other pollutants can adhere to soil particles. As the soil particles are eroded by stormwater, the attached pollutants are carried with them. These pollutants can end up in our lakes, rivers, streams, or wetlands. All of these impacts can be greatly reduced on construction sites with the proper use and maintenance of soil erosion and sedimentation control measures referred to as SCSC measures or best management practices, commonly referred to as BMPs, on construction sites.
As an inspector, you may not have to decide which SESC measures should be used, but you need to know how to properly install and maintain them. Be familiar with where and when they are appropriate and determine their effectiveness. It is important to remember that soil erosion and sedimentation are two different processes and therefore require different control measures. Soil erosion control measures are designed to prevent soil movement by wind and water and are the first line of defense. Sedimentation control measures are designed to remove eroded soils prior to leaving the site. The SESC measures need to work in conjunction with each other so that all aspects of the site are addressed. SESC measures can be either temporary or permanent. It is important to remember that usually a single SESC measure will not be enough to keep all the soils on site. Temporary SESC measures are removed once the site becomes stabilized. Phasing or staging is an erosion control practice that needs to be considered during the planning process. Plan the stages or phases of development so that only areas which are actively under construction have bare or disturbed soils. By working in small sections of the project and then stabilizing the section prior to disturbing a second section, it is possible to limit the amount of earth disturbance. As an inspector, you should verify that the project is proceeding according to the plan and that each section of work starts only as the previous section is stabilized. The most effective way to control runoff and erosion, and one of the most effective means of controlling sediment, is to keep the soil covered with vegetation, which shields the soil from the impacts of the raindrops, the force of the wind, and the energy of runoff. It increases the soil permeability and infiltration, provides a continuing supply of organic matter, which improves fertility and infiltration. It slows runoff to non-erosive velocities, and finally filters sediment out of runoff. To the extent possible, preserve existing vegetated areas. This eliminates the effort and expense of reestablishing vegetation. Seed and mulch all areas that have no vegetative cover as soon as possible, but no later than 5 days after achieving final grade. If it is not feasible to permanently seed, establish a quick-growing temporary grass cover or install appropriate temporary SESC measures. Seed may be applied by hand, mechanical spreader, seed drill, or by hydroseeding. Before seeding and mulching, topsoiling may be necessary. Topsoiling involves placing 3 to 4 inches of good quality topsoil, free of large clods and stones, on the final graded subsoil surface before preparing the seedbed. Native topsoil should be stockpiled away from surface waters, protected with temporary SESC measures, and reapplied to the site to promote rapid vegetative growth. On areas that require immediate vegetation or a high-quality turf, sod may be considered as an alternative to seeding. Sod is expensive and prone to failure if irrigation is not available. The sod must be installed with the joints staggered, seams closely abutted but not overlapping, and staked in areas of concentrated flow or with steep slopes. Mulching is essential when establishing grass or other vegetation from seed. Mulching involves placing materials such as straw over the seed to protect the soil from erosion and to provide a proper environment for the germination and growth of vegetation. Mulch insulates the soil from intense heat and cold and conserves moisture by limiting evaporation. Mulch can be applied by hand or with a mulch blower. On slopes, windy sites, or areas adjacent to roads, mulch must be anchored using netting, a tackifier, or a mulch anchoring disc. Many different combinations of mulch, tackifier, fertilizer, and seed can be applied with a hydroseeder. As an inspector, you must ensure that mulch is thick enough to provide adequate protection of the soil and is securely anchored. On steep slopes or in areas of concentrated flow, erosion control blankets or turf reinforcement mats may be required to properly secure the seeding. The blankets are generally made from straw, coconut fiber, or a combination of both, and are reinforced with netting. Refer to the manufacturer's specification for the proper application of erosion control blankets. Typically, erosion control blankets are installed parallel to flow. They must be trenched in at the top of the slope, overlapped at the sides, and secured with special staples or stakes. Care must be taken to ensure that there is a good contact between the blanket and soil. When selecting erosion control blankets, consider using biodegradable blankets and stakes when the area will be mowed or where wildlife such as snakes and turtles may get tangled in the netting. The inspector should ensure that seed germination is adequate, coverage is complete, and that erosion has not damaged the substrate, seed, or mulch. He or she should verify that mulch or erosion control blankets are providing adequate cover to protect the soil and seed and are adequately anchored. Materials planted in the spring should be inspected during the summer or early fall so any necessary corrective action can be taken during the fall planting season. Areas planted in the fall should be inspected early in the spring so that maintenance can be performed during the spring planting season. Surface roughening or scarification is an erosion control practice. It involves the creation of horizontal grooves on the bare surface of newly graded slopes. The horizontal grooves reduce runoff velocity and erosion potential. Roughened slopes also help to establish vegetation by providing increased surface area for seed, mulch, and fertilizer, and by promoting moisture retention. Surface roughening can also be used without seed in areas of frequently changing grade. Inspectors should ensure that the grooves are created perpendicular to the direction of runoff flow. Grooves can be created using a variety of equipment including discs, tillers, the teeth of a front loader bucket, or tracked vehicles. If a roughened surface is the final grade, seed and mulch should be installed within 5 days. Ensure that rilling or gullying has not broken through the roughened surface. It may be necessary to supplement the roughening with other SESC measures. Riprap is an erosion control measure. One of the most important things to remember is that no matter what purpose riprap is used for, proper rock size and thickness must be based on the maximum expected water velocity or wave energy. In most situations, filter fabric should be placed between the riprap and the soil. Rock that is too large may allow sediment transport between the rocks or may allow runoff to pass through at erosive velocities. If rock is too small, the energy of moving water may move the rock and destroy the structure. To keep the spaces between riprap structures free of sediment, bare soil upslope of riprap should be stabilized with erosion control blankets, sod or seed and mulch, or the riprap must be otherwise protected by means of temporary sediment controls. If placing riprap requires the reconfiguration of banks, slopes, or channels, filter fabric and riprap should be placed immediately after grading. The filter fabric and riprap should be keyed in at the top and bottom of the slope. The riprap should be installed before any concentrated discharge occurs. Diversions capture and redirect runoff and are considered both an erosion control and a sediment control. Diversions upslope of a construction site intercept runoff in order to prevent erosive velocities of stormwater runoff on exposed soils. Diversions below a construction site intercept sediment-laden runoff and route it to an area where the sediment can be contained. Extreme care must be taken when constructing diversions, because it often results in converting overland sheet flow into concentrated flow. This may result in the erosion of the diversion channel or the channel outlet. The easiest way to dispose of diverted water is directly into a sediment basin or onto well-established vegetation. It may be appropriate to combine a grade stabilization structure or an energy dissipator at the outlet to safely discharge water from the diversion. If this is done, the inspector should ensure that the outlet remains stable. The inspector should also examine the diversion for erosion and ensure that runoff is being captured by the diversion and not flowing around it, overtopping it, or creating erosion. Grade stabilization structures are erosion control measures that are used to carry runoff from one elevation to another and are often used in conjunction with diversions. All grade stabilization structures must be designed to carry the anticipated runoff from the site. Care must be taken to prevent scouring or erosion at the inlet or outlet, or along the side of the structure. Scouring can be prevented by one or more of the following methods. Place large rocks on filter fabric downstream of the outlet, use flared end sections, or place large rocks or concrete blocks in the flume channel. The inspector will want to ensure that water is not flowing downslope in places other than through the structure, and examine the inlet and outlet of the structure for piping and erosion. The primary purpose of check dams as an erosion control is to reduce water flow to non-erosive velocities in ditches, diversions, or other areas of concentrated flows. Check dams can also function as sediment controls if runoff is slowed sufficiently to allow large-sized particles to settle out of the water and be deposited upstream of the check dam. The deposition of sediment can be increased by excavating sumps upstream of the check dams. Check dams are generally constructed of rock. When constructing check dams, place the rock in the ditch and up the sides to a level above that of the anticipated flow. The middle of the dam should be 9 inches lower than the outer edges. This allows water to flow over the depression in the center of the check dam as opposed to around the sides where it could erode the banks. Check dams are usually placed in a series. They should be located or spaced so that the toe of the upstream check dam is at the same elevation as the lowest point at the top of the downstream check dam. Therefore, the steeper the slope, the closer the check dam should be. Stone size should be increased with increased slope and velocity. The stones should be big enough to stay in place during anticipated high-velocity flows. Temporary check dams made of a plastic grid are also available. Advantages of temporary check dams are: they are lightweight, they can be installed by hand in remote areas, can be easily removed when vegetation is well established, and are reusable. Permanent rock check dams often create traffic hazards, interfere with mowing or other maintenance, may be aesthetically undesirable, or may be difficult to place without damaging the surrounding vegetation. Instead of using permanent rock check dams, consider a vegetated channel lined with turf reinforcement mat with temporary check dams. To ensure that the check dam is properly constructed and functioning, the inspector will want to examine the channel bottom and sides of the check dams for erosion. Accumulated sediment on the upslope side of the check dam, or in the sump, should not exceed 40 to 50% of the original volume. If temporary check dams are used, be sure they are properly secured to the ditch bottom, are not damaged, and are not obstructed by debris. When the channel is well stabilized, schedule the removal of temporary check dams. A temporary SESC measure for controlling wind erosion is to keep the bare soil moist by watering. Water should be applied to the site whenever moderate to high winds are anticipated. Haul roads may have to be wetted continuously. Chemical binders can be added to the water before it is sprayed onto the soil surface. The chemicals penetrate into the soil and bond the individual soil particles, making them resistant to the forces of wind and water. One class of chemicals that are commonly used are polyacrylamides, or PAMs. Be aware that the surface application of certain chemicals may be regulated or even prohibited, depending on location and proximity to surface waters of the state. The inspector shall monitor soil moisture, dust potential, and recommend application as appropriate. If watering has occurred, ensure that excess water has not created unintended runoff, erosion, or sedimentation problems. If PAMs or other bindings have been applied, ensure that the binding qualities of the chemicals remain functional.
Silt barriers are sediment controls intended to remove sediments in runoff by reducing velocity, causing sediments to drop out of suspension, and by acting as a filter for water passing through the barrier. Silt barriers should only be used to filter sheet flow, never for concentrated or channelized flow. Silt barriers must be placed along a horizontal contour perpendicular to the direction of sheet flow. Several types of silt barriers exist. The most common are silt fence, straw wattles, and compost stocks. Straw bales are not an acceptable substitute for a silt barrier. Straw bales are impervious to runoff and act as dams, not as filters, particularly after they become wet. Runoff ponded behind the bales will eventually cause a breach, allowing a discharge of both runoff and sediment. Silt fence is one of the most commonly used SCSE measures. Unfortunately, it is also commonly misused and neglected. The fencing should be trenched in to a depth of 6 inches and backfilled with the stakes on the down gradient side of the fence. The fabric should be taut so it does not wave in the wind. If more than one course of fence must be joined end to end, the ends should be wrapped so there is no gap between courses. If possible, locate the silt fence away from the toe of the slope to enhance ponding and settling. When used as silt barriers, straw wattles and compost filter socks should be applied in much the same way as silt fence. Wattles must be staked, but compost filter socks may be heavy enough to stay in place without staking. Neither wattles nor compost filter socks have to be trenched in, but both must be installed along contour lines, and the ends must be secure so water and sediment cannot flow between pieces. When sediment accumulates to 40 to 50% the height of the barrier, the sediment must be removed. Barriers that have been damaged by excessive sediment loading, vehicle traffic, or general wear and tear must be repaired or replaced to restore its full function. A large construction site may have several hundred yards of silt barrier. It is important when doing inspections to accurately record the location of any problems. Ensure that sediment accumulations are not excessive, that filter materials and stakes are in good condition, and that silt fence remains properly trenched in. Dewatering is the removal of groundwater, surface water, or stormwater from a site to allow construction to be done in dry conditions. The water that is removed from such an area must be discharged to a stabilized area at a non-erosive velocity. If the water is laden with sediment, measures must be taken to remove the sediment prior to its reaching a water body or storm inlet. Sediment-laden water may be pumped through geotextile filter bags into sediment basins or through filter berms constructed of stone. If the suspended sediments are clays or fine silts, it may be necessary to introduce PAMs into the discharged water to facilitate filtration or settling. The inspector must examine the suction inlet to ensure it is functioning properly and not clogged. It is important for the inspector to be sure the discharge is not causing erosion or carrying sediments to surface waters of the state or adjacent properties. When dewatering to a filter bag, sediment basin, or other structural containment system, the inspector must ensure that the discharge hose remains in place and that no sediments are leaving the containment system. To prevent sediment from being carried out of construction sites in the tires of vehicles, rock construction exits can be implemented as a temporary sediment control measure. Rock construction exits should be installed prior to the commencement of construction activities. At all designated exit areas, filter fabric should be placed on the soil surface and covered with a bed of 4 to 8 inch diameter crushed rock or stone. The exit should be at least 50 feet in length and wide enough to accommodate construction vehicles. Rock construction exits provide an area that allows soil from vehicles and equipment to fall off tires prior to being tracked onto the primary road. Thus, to be effective, egress from the site must be limited to the exit road. Exit roads need to be maintained periodically. This can be done by adding new layers of stone as the old layers become compacted. Periodic street sweeping in the vicinity of the exit roads may be necessary even with the use of rock construction exits. Sediment that collects on the shoulder of the roads or the curb systems from the sweeping activities must be removed. If a large amount of sediment must be removed, or if sweeping the sediments is likely to create excessive dust, use another means of removal or dampen the sediments prior to sweeping. If tracking of sediment cannot be controlled with rock access roads or sweeping, wheel wash systems may have to be installed. These systems are used to spray the sediment off the wheels and undercarriage of vehicles before they exit the site. The inspector should check their road for sediment and, if present, request to schedule sweeping or other means of removal and determine the cause of the problem. Sedimentation basins are common sediment controls used on construction sites to trap sand and large silt-sized sediment carried by stormwater runoff. In general, basins are not effective in removing clay and fine silt. For effective sediment control, basins should be at least 4 times as long as wide, with the inlet and outlet at opposite ends, and the outlet at a higher elevation than the inlet. Baffles or meanders can be used to increase the treatment time if site constraints do not allow for a long, narrow basin. After a storm has passed, it is often advantageous to lower the water in the basin below the top of the riser pipe to create storage volume to accommodate the next storm. The surface of the basin will become less turbid as the sediment settles to the bottom of the basin. It is preferable to drain the basin from the water surface through a riser pipe rather than through a discharge pipe located at the bottom of the basin. This can easily be accomplished by using a perforated riser pipe instead of a pipe with solid walls. To minimize the loss of sediment passing through the holes, the riser pipe should be wrapped with wire mesh and surrounded with pea stone. Inspectors need to examine the basin outlet and ensure that water leaving the basin is not carrying sediments and that no erosion is occurring at the point of discharge. Sediment discharge and erosion around the outlet are signs that the treatment time needs to be lengthened and the velocity of exiting water needs to be slowed. Periodic cleaning is essential to maintain the function of a sediment basin. Sediment should be removed in dry conditions when the depth of the sediment in the basin is 40 to 50% of capacity. Storm sewer inlet protection is a sediment control. Storm sewers are often direct conveyances of stormwater to surface waters. During construction, all storm drain inlets must be protected from sediment inputs in order to prevent storm sewer clogging, over-sedimentation of detention basins, and to protect lakes, streams, and wetlands from direct discharges of sediment and other construction-related pollutants. There are several methods of inlet protection. Inlets can be sealed with an impervious material if runoff can be contained on site. However, on most construction sites, it is necessary to discharge stormwater even during construction. On reconstruction sites, it is important to protect both the existing and newly installed storm sewer. Let's discuss a few ways to protect storm sewer inlets on construction sites. Bags are one of the most common methods of inlet protection. They are made of filter fabric and are designed to be inserted below the grate of a storm sewer inlet. They allow water to pass through while containing sediment. They usually have loops to facilitate removal and cleanout. Filter bags should be inspected regularly for sediment accumulation. It is never recommended to place flat filter fabric under a storm grate as inlet protection. Most rolled fabric materials are not suitable for the drainage needed in a drainage system. The fabric will easily clog and cause flooding. Removal is also difficult because there is nothing to prevent the soil and fabric from dropping into the manhole. In contrast to placing the fabric under the grate, filter fabric and filter mats may be placed on top of the grate and over the curb cut on street drains to filter small quantities of sediment. These controls require constant maintenance. The fabric must be replaced and the mat cleaned after every runoff event. The above controls should never be used on flat, low-profile grates or yard drains. They will quickly become clogged and cease to function. Yard drains can be protected by using products that consist of an elevated frame covered with filter fabric. Another method of inlet protection is properly installing silt barriers around the perimeter of the drain inlet. Finally, a filter made of coarse gravel or pea stone may be placed in front of or around the drain inlet. The gravel provides a certain amount of filtering action and is highly resistant to erosion. Standard concrete building blocks or wire mesh are placed on the inside of the gravel filter to keep stones from being washed into the storm drain inlet. The configuration of the filter will depend upon the type of inlet being protected. The inspector needs to check for clogging of fabric or screens, overtopping, and structural integrity. In particular, ensure the structures are protected from and not damaged by vehicles. If sediment accumulations are sufficient to impede function, schedule sediment removal. Sediment should be removed from inlet protection devices when the device is 40 to 50% full. Sediment removed from inlet protection devices should be moved to a stable location to prevent further erosion and sedimentation. Turbidity curtains provide temporary sedimentation control for earth changes that occur in water bodies. Turbidity curtains isolate the turbid water that is generated by excavation to a stream or lake bottom. Disturbed soils that settle along the bottom of a turbidity curtain must be removed from the lake or stream before removing the curtain. Before installation, verify that the turbidity curtain has enough depth to reach the lake or stream bottom. Turbidity curtains must be installed parallel to the flow of water. Turbidity curtains that are too short or installed across a channel will allow sediment to flow over or under the device.
There are both federal and state regulations that guide the use of these measures to protect our land and water resources from the impacts of soil erosion and sedimentation. In 1994, the state of Michigan compiled all of their environmental laws into one all-inclusive statute called the Natural Resources and Environmental Protection Act, often referred to as Act 451 or NREPA. The primary sections of Act 451 related to stormwater and soil erosion and sedimentation control are Part 31 and Part 91. We will now discuss the requirements of these parts. Part 91 and the rules associated with it regulate soil and off-site sedimentation from earth change activities. The primary goal of Part 91 is to protect adjacent properties and surface waters of the state from sediment generated from unchecked erosion. Part 91 or SESC permits are generally required for any earth change that disturbs 1 or more acres of land or that is within 500 feet of the water's edge of a lake or stream. Permits must be issued to the landowner or easement holder. There are 3 categories of agencies that have responsibility for administering and enforcing Part 91 throughout the state. Counties are required by statute to administer and enforce Part 91. The County Board of Commissioners of each county must designate an agency referred to as a County Enforcement Agency, or CEA, to be responsible for administering and enforcing Part 91 within the county. The CEA is responsible to review SESC applications and plans, issue permits, inspect the permitted sites, and take any necessary compliance and enforcement actions to ensure that the sites remain in compliance with Part 91 and the rules. A municipality may elect to administer and enforce its own SESC program. In order for the municipality to administer its own program, the municipality must adopt an ordinance and designate an agency referred to as a Municipal Enforcing Agency, or MEA, to administer and enforce Part 91 within the municipality. Upon approval of the DEQ and designation as an MEA, the CEA no longer has authority to administer and enforce Part 91 within the municipality. The MEA assumes the same responsibilities as the CEA previously had in regards to plan review, permit issuance, inspections, and compliance and enforcement actions. State, county, and municipal agencies that undertake earth change activities may apply to the DEQ for designation as an authorized public agency, or APA. To be designated as an APA, the agency must submit SESC procedures to the DEQ that detail how it will minimize erosion and off-site sedimentation while undertaking earth change activities. Upon approval of the SESC procedures by the DEQ and designation as an APA, the agency is no longer required to apply to the CEA or MEA for SESC permits. It is the responsibility of the APA to develop SESC plans, implement the plans, conduct inspections, and take any necessary compliance and enforcement actions to ensure all sites are in compliance with Part 91 and the approved SESC procedures. CEAs and MEAs have no oversight responsibility for APA projects. It is the responsibility of the DEQ to ensure that all agencies comply with Part 91. Any violation of Part 91 subjects the permittee or APA to fines and penalties of up to $25,000 per day per violation. In addition, lack of adequate inspections or compliance and enforcement actions can result in CEAs being placed on probation and MEAs and APAs having their Part 91 agency designation revoked. Part 31 of Act 451 is the section of the law that Michigan uses to implement the Federal Clean Water Act. The primary goal of Part 31 is to protect and conserve waters of the state. Part 31 prohibits the degradation of state waters, requires permits for wastewater discharges, and it gives the state authority to develop rules and issue permits to achieve water resource protection. An example of this was the development of the permit by rule to obtain stormwater coverage for construction activities which disturb 1 acre or more of land and have a point source discharge of stormwater to surface waters of the state. The permittee must be the landowner or recorded easement holder and must be the same person that the SCSC permit is issued to. To obtain stormwater coverage, the permittee must obtain Part 91 coverage first, either by obtaining an SCSC permit or by being an APA. For earth changes 1 to 5 acres in size, stormwater coverage under permit by rule is automatic once the SCSC permit is issued, or if work is being conducted by an approved APA. For earth changes 5 acres and greater, a notice of coverage form must be completed and sent to the DEQ, along with a site location map, a copy of the SCSC permit, a copy of the approved SCSC plan, and the appropriate fee. Once the DEQ receives the completed notice of coverage, appropriate documents, and fees, stormwater coverage begins and construction can commence. A letter acknowledging receipt of the notice of coverage will be sent to the permittee and the SCSC agency. If the form was incomplete or other required documents were missing, this letter will identify additional information needed before coverage can begin. Once coverage begins, there are requirements that must be met to remain in compliance with the permit by rule. These requirements include the following. The permittee must remain in compliance with the site's SCSC permit and plan at all times. Be aware that if the SCSC permit expires, the notice of coverage expires as well. Also, the SCSC measures must be under the direct supervision of a stormwater operator. There shall be no discharge of any injurious substances. The SCSC measures must be properly inspected, maintained, and the site conditions must be documented. All inspection logs must be retained for DEQ review or public inspection for 3 years. The permittee must file a revised notice of coverage form before any expansion of the construction activity or change in the local SCSC permit. The permittee must file a notice of termination for sites greater than 5 acres when the site is stabilized. If this is not done, coverage, including the inspection requirements, remain in effect. Failure by the permittee to meet these requirements is a violation of Part 31 and is subject to the fines and penalties of up to $25,000 per day per violation. Now that you have a general idea of the rules, regulations, and SCSC measures, let's look specifically at what you, as the stormwater operator or SCSC inspector, are required to do.
Whether you are a Part 91 SCSC inspector or a Part 31 stormwater operator, you should thoroughly review the SCSC plan and any special permit conditions prior to visiting the site. Identify key areas of the project, such as critical areas, which are areas that are difficult to stabilize, sensitive areas, which are areas located near lakes, streams, or wetlands, areas where SCSC measures have been implemented, and discharge points. An inspector for an APA may be both the SCSC inspector and the stormwater operator. For SCSC inspections, the person conducting the inspections on behalf of the Part 91 agency must complete the SCSC training required regardless if a project is permitted by a CEA or MEA or undertaken by an APA. The inspector must be familiar with the project site, the SCSC plan requirements, installation and maintenance details for the required SCSC measures, and the requirements of Part 91, the rules, and applicable SCSC ordinance or APA SCSC procedures. The SCSC inspector must regularly inspect the entire project site to determine if the SCSC measures are properly installed and maintained in accordance with the SCSC plan and if the SCSC measures are effective in minimizing erosion and off-site sedimentation. Inspections should be conducted at a minimum just before or after earthwork begins to ensure that temporary SCSC measures are in place and functioning. Routinely throughout the project during major changes in work activity, after major rainfall or snowmelt events, and prior to closing out the permit to ensure that the site is stabilized and completed in accordance with the SCSC plan and permit conditions. It is recommended that the CEA or MEA inspect the proposed project site prior to issuing the permit. However, that inspection should be conducted by the agency person responsible for developing or approving the SCSC plan and issuing the SCSC permit. All observations made during the inspections and any necessary corrective actions and timeframes to make those corrections must be documented on an inspection report. A copy of the inspection report should be given to the on-site person responsible for the project or mailed to the permittee. In addition to verifying that prescribed SCSE measures are properly installed and maintained, the inspector should continuously be looking for potential problems that may occur on the site during the next strong wind, rainfall, or snowmelt event. It is much more effective to prevent a sediment discharge from happening than fixing the problem after it occurs and damage is done. If corrective actions are required, the SCSE inspector must conduct timely follow-up inspections which coincide with the time frames set forth in the inspection reports to ensure compliance with the requested corrective actions. Timely is a relative term and can range anywhere from immediately for discharges to waters of the state to 24 hours for minor maintenance issues, to up to 5 days for corrective actions requiring major plan revisions and/or significant adjustments to existing SCSE measures. The potential for resource damage also influences the amount of time allowed to make the necessary corrective actions. Each inspector should refer to their agency's written procedures to determine the proper protocol. Anytime there is a discharge or potential discharge of sediment to the surface waters of the state, corrective actions and follow-up inspections should be done immediately to within 24 hours of discovery. For other more substantial corrective actions, the maximum allowable time by law to comply is 5 days after notification. Immediate steps should be taken to cease a discharge and to install temporary control measures until permanent measures can be implemented. If corrective actions are not completed within the specified time frames, the inspector should proceed in accordance with the Part 91 agency's compliance and enforcement procedures or guidelines. It is the SCSE inspector's responsibility to verify that earth changes that require SCSE permits have SCSE permits, that SCSE permits are posted, and the approved SCSE plans are available on site. All inspections should be conducted in a manner and frequency to assure minimization of erosion and off-site sedimentation and must be properly documented. During the inspection, the inspector shall do the following. Ensure that temporary SCSE measures are installed before or upon the commencement of the earth change activity. Verify that SCSE measures are properly installed and maintained per standard details or plan specifications and that the measures are effective and appropriate. Ensure that sediment does not leave the project site or discharge to surface waters of the state. Ensure that water is discharged from the site at non-erosive velocities. Ensure that permanent SCSE measures are installed on all slopes, channels, ditches, or any disturbed land within 5 calendar days after final grading or the final earth change has been completed. Verify that permits are not closed out until the site is stabilized and the temporary SCSE measures are removed. Ensure that compliance and enforcement actions are taken in accordance with Part 91 agency's compliance and enforcement procedures or guidelines, Part 91 and the rules.
Construction stormwater inspections must be performed and documented by a stormwater operator. The stormwater operator must perform weekly inspections and an inspection within 24 hours of a precipitation event that results in a discharge to surface waters. The stormwater operator must document site conditions, including deficiencies in the SCSE measures and corrective action required or completed. Inspections must also continue through the winter months if construction is ongoing. If construction has ceased through the winter months, the site is temporarily stabilized and the ground is frozen. Inspections are not required. However, the inspector is still required to fill out the inspection report form documenting that conditions are such that it is unlikely for a runoff event to occur. Anytime there is snowmelt or precipitation that results in runoff, inspections must resume immediately. The stormwater operator conducts inspections, keeps a written log of the inspections, and informs the permittee of needed corrective actions. It is the responsibility of the permittee to maintain the site and stay in compliance with the permit by rule conditions. In many cases, the permittee relies on the stormwater operator to help them remain in compliance. By law, stormwater operators are not required to design, install, or maintain the needed measures unless an agreement has been made between the stormwater operator and the permittee. The main duty of the stormwater operator is to inform the permittee of problems and corrective actions needed on site. The best way to do this is to know the site and be aware of problems so they can be corrected or, better yet, prevented. Remember, it is less expensive to prevent problems than it is to correct them. The stormwater operator should have a copy of the SCSC plan when inspecting the site and should verify that the measures noted in the plan are in place, adequate, properly functioning, and if they are in need of maintenance. The entire site should be inspected each time. New problems can occur with changes in work areas or at different stages of the project. Do not limit your inspection to the existing SCSC measures. Look around and be aware of areas that may need improvement. Inspections following precipitation events should be performed with the idea that some measures may need maintenance or replacement after the event. These inspections will allow you to see the drainage pattern on site. This makes it a good time to look for areas that need protection that were not expected in the planning stage. The logs or inspection reports should reflect everything found during the inspection. Complete logs are essential for communication between the stormwater operator and the permittee. The logs should detail the condition of the SCSC measures on the site so that the permittee can use them to guide corrections. An on-site file review is recommended for the inspection logs. They should be up to date and available for review. These records are very important to show what has occurred on the site. It is the responsibility of the stormwater operator to inform the permittee of any findings and provide them with the inspection log. Here are some common scenarios that you may encounter in your role as the stormwater operator. If the SCSC plan is followed and no corrective actions are needed, complete the log appropriately. One copy of the inspection report should be sent to the permittee and another copy must be maintained on file. If you find that the SCSC plan is being followed, but there are areas that need corrective actions, complete the inspection report and inform the permittee. If you find recurring problems, they should be noted in the inspection logs. If you find that the SCSC plan is inadequate to properly manage soil erosion on site, notify the permittee. A major problem is failure to maintain the SCSC measures. Often, good measures are installed but not properly maintained, leading to more and costlier problems later on. Once the construction is completed, a final inspection should be done by the local SCSC agency to verify the stability of the site prior to closing out the SCSC permit. It is necessary to ensure that the site is truly stable before terminating the coverage. A stable site has all permanent structures in place and the vegetation is fully developed. Remember, any stormwater that contains sediment and other pollutants discharging to surface waters of the state may be a violation of Part 31, Part 91, and Permit by Rule.
This concludes today's discussion. In summary, as a stormwater operator or SCSC inspector, you are an important link between earth change activities and the protection of our state water resources. Having a good understanding of how SCSC measures function properly, performing adequate and appropriate inspections, keeping detailed reports or logs, and communicating with the permittee will all help you to fulfill the goals of your role as a stormwater operator or SCSC inspector. Your efforts in these areas will ultimately prevent negative impacts of runoff and protect the invaluable surface waters of our state.